device.
Yeah, so
That one.
as an example, we have an operator that is the customer.
We're good.
Yeah, we got audio.
One of these days. And the operator
This is actually a good experience.
change that. So check the site. Okay, now we have the namespace. Now you can create these things in the namespace. Update that. Okay, so I'm gonna watch that.
All right, welcome everybody to Utah Rust.
No. Sorry.
No, Todd. You're being recorded.
And
Anyway, glad everybody could come today. We're skipping introductions today because I'm so slow getting stuff set up. We can introduce ourselves later. So we've got a couple fun things today. First off, we've got a presentation by Garrett, writing Kubernetes Operator in Rust. This is his first time presenting here, so thank you for presenting. Appreciate it. And then when he's done, we'll have a couple other things. I'll present some options to you at that point, so we'll go to that point. Garrett, take it away.
All right. So, hey, I'm Garrett. I'm doing a talk on Kubernetes, writing operators in Rust, and the first thing I want to talk about has nothing to do with either. But I feel like I feel like this talk is going to look like an introduction to Kubernetes in a slightly different way than a lot of other intro to Kubernetes talks start. Then we're going to do some writing in Rust, and then we're going to end and just kind of talk. But
So you're going to teach us what Kubernetes is and how it works?
well, I feel like if I say let's write like an operator in Kubernetes, like there's a lot to unpack there, and I feel like that's really where we should start. So if we honestly don't even get to the Rust stuff, I think that's still a successful thing, because in my mind, Kubernetes is like this term. People say, well, what the hell is it anyway? It's a way of running containers. Like it's an automated way of running containers. But it's obviously, there's a lot more to it. There's a reason. There's like, people say it's really complicated and they want to avoid it for certain things, or why some other solution is better. But Kubernetes has become like the de facto operating system for the things that you want to run. Like it's everywhere, in every cloud platform, and you can pretty much take anything you have in one and run it in another, and that's pretty cool. So
As long as you write enough YAML.
as long as you write enough YAML, and I want to kind of dissect here for a second, the reason Kubernetes was built the way it was is one of the major reasons I think it became so popular, and that's because it has this concept of like controller loops or operators. But let's work our way from bottom to top. The first thing I want to do is like consider a TV remote, because we just used one a minute ago to turn the TV on, and everyone has probably 10 in their house, even if you only have one TV. But like the joke here is a TV remote is like the stereotypical design by committee. It's like, well, just add an extra feature. Like we need a button for Samsung TV Plus, which I don't know if that exists, but it's probably on over 1 million remotes in the world, and they ship that feature really hard. But the reason the other reason I want to consider a TV remote is there's like more than one way to do a thing. And like maybe I don't know if you've looked at a TV remote as long as I have thought about this, but take like changing a channel. Why are there two ways to change a channel on a remote? There's this channel button where I can increment by 1 or decrement by 1. And then there's this number pad where I can type in the number that I want to. And like if we were to turn those into almost commands, they could look something like this, right? I could say change the channel increment by 1, or change the channel to some channel number 60. And it's almost like I can wear two hats, right? I can tell the TV that I want to watch channel 60, and the TV will figure out how to get there. Or I can say, I'm the boss, and I'm going to tell you what to do. And I'm going to hit channel up 50 times because I was on channel 10 and I like pain. And if my dog jumps in front of the TV and the IR signal misses it, it's like, I'll know that I'm only on 59 after clicking it 50 times, and now I'm going to go to channel 60. And so here we enter the philosophical meta world. Who is the real controller in this situation?
Dog.
The dog, right? The dog is like the cosmic ray that hits our memory and messes our lives up. No, but it's like, you see what I'm saying? Like, yeah, we're using remote control, but it's like you have to tell the TV what to do.
So we're the Kubernetes controller, and we write ourselves in Rust?
What is going on? Here's a fun experiment to think about, though. Changing the channel is not that big of a deal. I'm going to pose a scenario to this group, and I want you to solve it. So this is what I want to happen. My question is, at your house, how would you do this? You got your child, niece, or neighbor that you're babysitting because you're kind, and they want to watch Frozen, but they want to start where Olaf sings about summertime, which ChatGPT said is at that time stamp. You want to make sure the volume is loud enough for them to hear, but not too loud that you go crazy watching it for the 50th time. And subtitles drive you crazy, so you have to turn those off every time because they always turn on. So how would you do this? I mean, this is not a hard question, Spencer.
Get a Raspberry Pi and an IR, and then you write this.
No, you're not writing code, but like literally, how would you do this?
A lot of button pressing on the remotes.
You have to set an alarm for like, or set a
Turn your TV on.
stopwatch.
Oh, we're starting from scratch here.
Turn your TV on. Where is Frozen found on your TV?
Disney Plus,
Disney Plus. We have to go to Disney Plus. Then what do we have to do?
find Frozen.
Find Frozen. Maybe it's on the homepage because I don't know.
Maybe it's not.
Or maybe you have to
figure out
type it in.
with, there you go, with Disney Plus, you gotta find the right category, you gotta go into the category, you gotta get your other remote, you gotta press the volume button a lot of times, then you gotta get your old remote, you gotta scroll to the right place, you gotta, then you gotta figure out where in the menu the subtitle button is, because you can't find it.
Yeah, you hit up 4 times, but it doesn't go to the bar that has the subtitles. But eventually you get it off, and the snowman's happy or wants to know what it feels like in summer. I was thinking, like, what if we were to create this as like state as code, right? It would probably look something like this, where we say, I want to watch a movie, it's called Frozen, begins at an offset, volume, and turn off the subtitles. And now, I can give this to any of you and your TV setup at home, provided you have Disney Plus, and you can make this happen, right? And like I said, this is what I want, and you found a way to make that happen. One more like stupid example is my aunt told me the other day my printer doesn't work. And all she knew was she wanted the printer to work. And she looked at me and said, you can make it work. And she wanted me to get to that happy state as fast as possible. And I said, no, thank you. I don't do that anymore. So what are all these examples really getting at? I guess I have one more, which is Google Maps. We'll skip it, right? But I want to introduce this idea of focusing on the end state. If you can communicate what you want, there's ways or people or code that can help you get where you want to go. Like Google Maps tells you how to get to St. Louis from Vegas, and all you have to do is follow steps. This is kind of where we introduce this concept of a controller in the Kubernetes sense. This is like the third time we've used the word controller here, or the third definition. But I found this online. I think I forgot to attribute it, but a controller is responsible for incrementally moving the current state to the desired state. They do this through a process called reconciliation. In other words, it is used to describe a process that looks at what's happening now and drives towards the ideal end state as fast and optimally as possible, which is, again, everything we've talked about. It's the same thing. And I like this diagram, right? I need to see what's happening and make the incremental steps to get to where we need to go, and ideally do it as fast as possible. So it is a little warm.
I'm going to see if I can get the AC going.
It is a little warm. So let's pause there for a second. We're now introducing Kubernetes. I mentioned that it is like this automated way of running containers. One thing that I want to highlight here with Kubernetes is it has this concept called a resource. So like a deployment, a service, a pod. In fact, who's used Kubernetes before? A lot of people. So you're familiar with a lot of these terms. Like there are resources that you can create. It looks like a ton of YAML. But did you know that the API in Kubernetes is really stupid? Like normally if I was writing a web app and I want to like create a user, for example, or if I want to create a user, I'll probably have something that's like save the user and then some business logic like go send it a welcome email or send a notification or whatever, right? There's typically like this data that I save in my web controller or this web API, and then I'll probably have some business logic to go with it. In Kubernetes, there is no business logic. The API is basically a key value store. It just holds that YAML as an object. That's it. What's interesting though is it gives you standard CRUD operations plus this other one called watch. And what watch lets you do is basically say, hey, I want to subscribe to these resources, and if anything changes, just let me know. And hopefully a light bulb went off and said, that sounds like something I would need to write that control loop that says, observe what's happening and make changes along the way. And like the reason I think that's cool is Kubernetes has these built-in things to deploy your containers and run this stuff. But it's not built into the API. They're built as separate applications that just subscribe to changes from the API. So when the API changes, they take action, which means you can do that yourself if you want to. You can subscribe to it. And in fact, later on we'll see we use the same API to add our own resources, and we'll subscribe to our own changes, which is pretty cool. Any questions, like really quickly? Good?
Kubernetes really is just a key value store for YAML and just other random programs that watch it.
Yeah, well said. It's just a bunch of YAML and other programs that watch the YAML.
Until recently, you actually had to talk to the key value store directly rather than through the Kubernetes API. That was great.
So let's take this object on the right. It's a deployment. It runs two Nginx containers. If you're a deployment, you kind of need to consider these four things, right? Like how many copies of this app should I run, or how many containers should I run? I need to know if those things are healthy, some kind of health check. I need to be able to roll out a new version, and if that rollout sucked, I need to be able to roll it back to a previous version. And so my question is like, how does the controller manage this much complexity in a single loop, like in a single looping function? What do you think? How does it manage this much complexity?
Rust.
With an operator?
So yeah, they don't definitely write in Rust. We'll talk about operators. It's kind of step by step. It's a cheat. It's a stupid question because it doesn't. What it will do is it'll say like, I'm a deployment, I only do so much. I'm a replica set, I do some more. I'm a pod, I do a little bit more. And the point here is it creates all these little primitives, and each little primitive or each resource has its own control loop. So there's more than one controller in Kubernetes, which means if I'm a deployment, all I need to do is create a replica set, which has a specific version of the app and says how many pods should run. The replica set creates that many pods. The pods make sure the containers start and are continuing to run. Visually, it looks like this, where I'm a deploy. A deploy creates a replica set. A replica set creates the pods needed to run it. This is from a different example. I screenshotted from work, but does that make sense? Like, I really like this.
What's the function of a replica set again?
So a replica set is there'll be one deployment, but there will be a replica set for every version up to a certain number.
Okay.
And if you need to roll back, then it can say this is the old state, and we need to flip back to it. And that's how it solves that being able to roll back to a known old version.
So a deploy is sort of permanent. It's the replica set that you keep deploying.
The deploy will create, it's not you, it's the deploy says, oh, I have a new version. I need to create a new replica set. My job is done. The replica set
what
says,
we will do is say, hey, I have a new version.
you just update the deploy with your new container image or whatever.
Oh, okay. So you
Or your new
update
labels.
the deploy definition.
Yep. And it will say, oh, I need to create a new replica set. and it will tell the old replica set to wind down and the new replica set to wind up. And that's how it does a new deployment, and it can roll back by keeping that old state.
And then the pod is a set of containers on a host.
Yep, it's just a bundle of containers. Todd?
It will help if you separate in your mind that the idea of a deployment is a whole thing that has a current state and a desired state. The desired state is the thing you interact with in the API.
So I change the desired state of my deployment, and it's like, oh, okay, I'll go do things now.
Yeah.
Yeah, exactly. You tell it exactly what you want to have happen. Like maybe I could say, Nginx, I want to run on version 14.3. That's all I tell the deployment. Like I just tell I just say, update this deployment, and the deployment controller will say, oh, I need to go build a new replica set. And the replica set's like, I was just created and I don't have any pods yet. I'm supposed to make 2 of them. And that's it. So we get these like really nice separation of responsibilities and like these really cool building blocks where you'll never build a replica set yourself, but you may want to write some code that builds a pod yourself, and you don't want to have to figure out how to start containers, handle logs, networking namespaces. Just create a pod and it will manage all of that for you. So these like resource building blocks are a really powerful part of Kubernetes, and they're all just different control loops with a limited scope of responsibility. Just as long as it knows what it needs, and that's about it.
But the purpose is to keep the containers running all the time.
Yeah, so the pod, so let's say the pod, for example, if I need to run an Nginx container, what happens if that, well actually, let's pause there for 1 second and go back to this Frozen example. I'm now watching Frozen. You are back to the human controller that we were talking about before. The kid grabs a hold of the remote because they just touch everything, and all of a sudden they press the volume up button like to the max. And you come running in the room because it's like, you do not want to hear about summer snowmen at that volume. Like, what do?
We change the volume back down.
You change the volume back down,
You
right?
get a timeout.
Right. So what happens if your pod and a container crashes?
Restart.
You restart it. It's the exact same thing.
So in the analogy, when we become the controller, are we Kubernetes, or are we?
So it's you are watching a resource in the Kubernetes API.
Okay.
You're watching the TV resource, and the volume just went super loud. So you're saying, I need to turn this back to a reasonable volume, in this case, 25%.
To match that code.
To match,
Because you're
yeah.
saying I'm constantly in front of the TV matching whatever that state is.
Right, so you're saying this is what I wanted to have happen, you're just gonna turn it back to that.
So in the analogy, this is the config for a deploy.
Yeah, so this would be like the config for a deploy, and maybe the volume analogy is Nginx just crashed. And so the pod loop will restart it. Or what happens if like I delete a pod? Like I'm being malicious and I delete one of the 2 Nginx pods that I want to have run. What happens?
Recreates it.
It just grows.
The replica set will say a pod was deleted that it owned, and it needs to recreate one because now it has 1 and it was supposed to have 2. So super simple, just observing the world and making fine adjustments along the way. Question?
Replica sets controllers, are pods controllers, or deployments controllers?
Each of them.
Each of these are their own controllers.
Okay.
So controller, controller, controller. In fact, basically everything you see on this list, even though we're not talking about them, they all have their own controllers to make sure you're doing the right thing. So what is an operator? Oh, question.
Yeah, so is it just in a loop sampling whatever it's watching, or does something send a request to that saying, hey, this resource was just deleted, or what's the way it updates?
It's like subscribe to everything. It's like one.
Yeah, that's a great question. So back to the API, it's kind of like your standard stuff, but it also has this watch. So I can say watch deployments or watch pods, and if something changes to one of those files, then I can, one of those resources, I will be notified. And when I'm notified, I can take action because something happened with it.
But doesn't it automatically rebuild things? Like if you say, I want 3 pods, or like, doesn't it automatically always have those 3 pods, and if they go down, they just come back?
So the question is, if I have, in this example, 3 pods running, and they're always running, if I delete one, shouldn't it just automatically come back?
Yeah.
The answer is, it comes back because the replica set is watching it and says, hey, a pod was just deleted. I only have 2 of 3 pods running.
Right.
I need to go create another pod because that's my responsibility.
So the thing that does that is not Kubernetes itself, it's the replica sets controller specifically.
Right.
And that is a program.
And that's just a program.
Yeah.
So can, say, so does the controller logic manage state? So like, you know, if it fails, it'll try to restart it, and if it does it 5 times, then it will roll back. Like can you build that kind of stateful logic into your controller? Is that where that lives?
You cannot build stateful logic.
There's no feedback mechanism, so you can't fail and just stop. You have to keep trying, and then you will log events that somebody might care about someday. But the reconcile loop is eternal. Just eternal.
So it just always tries to restart it if that's the logic.
Yeah.
And if
So
you don't do that, then bad things happen.
If the desired state still says 3 pods and the 3rd one always crashes, it's always going to keep trying to create it because that's what the desired state says.
If you wrote
But
back,
if something else notices that you've had a bunch of crashes, then it might change the desired state.
Okay.
The replica set will like mark its own status as unhealthy if something is going bad.
Okay.
And then the deployment can also observe that one of its replica sets is unhealthy, and then it can use whatever configuration logic it has to decide, okay, that replica set failed. I'm told that I'm supposed to roll back, so maybe we should turn that one down and go back to the old one. But it's like they're all communicating with each other through just setting their status and then waiting for the other one's control to check the status.
yeah. So this is going to sound, for a lot of folks not super used to this, really complicated. But what I'm trying to at least show here is it's just like a bunch of while loops watching resources on an API. It's a watch call. It gets changes for the things it cares about, and it runs through a while loop. That's it. It's as simple as that. It's just really well balanced to create. It's just a really good design that lets you make things like complicated deployment structures with the ability to roll back, right? There's no, if you need state, you build a resource to hold the state that you can create.
It's literally a finite state machine, if you're familiar with that.
Yeah,
And that's not a new thing at all.
yeah.
so, but I think if you, like, you can run just Docker containers, but then Kubernetes is like, I'm gonna make sure all your Docker containers are running all the time. Like, that's kind of,
Yeah, the pod controller. So you just want to run a container. The pod resource is just a controller that says, oh, this was created. I got to figure out a place to run this container, a place to, and that should store the logs for it. It should have networking. The networking should be sandboxed just to this pod. It gets all of that for you, and if that container crashes, but the pod still exists, it will restart the container. But like all of that management of like the container lifecycle, so to speak, is encapsulated within the pod controller. It owns all the logic to run a container. And then the deployment and the replica set, they run multiple pods. And the pod, they gain the benefit of having a really smart pod controller that does everything right all the time. So just back to the original point, these are just building blocks where you can take really good tools off the shelf and use them as you see fit. So what the hell is an operator? Because we've said the word controller 2 million times. And the answer is kind of dumb. Kind of like a kube API. An operator is just a controller.
So they don't use the word controller?
They use the word controller and they use the word operator, and people will use them interchangeably.
They use both the terms for the same thing?
They use both the terms for the same thing. However, it's a really squishy term, which is like perfect for a group full of software engineers who care about this stuff way more than anyone should. Though what I've found is an operator is just a controller, but for maybe something custom. So deployment, pod, whatever, we'll call those like built-in things.
So the built-in controllers are controllers and the custom controllers are operators?
As far as I can tell, that seems to be the emerging consensus. Basically, people called them controllers, and then along the way, I guess CoreOS started using the word operator, and people are like, those folks are super smart. We should definitely start adopting that term everywhere. Now, there is some credit to use that term, whereas like a controller is looking for, like, is this pod running? They kind of say an operator should be more like, I want a Postgres server, it should have correct replication, it should have backups, and all this stuff, these jobs that need to run to do maintenance tasks. I'm gonna write an operator that has all this custom stuff and manages this very almost stateful system and just orchestrates it for you perfectly. So it's almost like an operator is a bunch of custom controllers in a package. We're talking like low, like engineering semantics here.
Yeah, I think the only difference is that it resides outside the core logic.
And that's the it resides outside the core of Kubernetes, and we're just going to go with that.
Another important distinction is you can look at the state of the operator separate from everything, because it's typically another pod. But you could do an operator outside of Kubernetes, but don't do that. So you can like look at it in the Kubernetes API, so it's kind of a meta thing. There's a layer between there.
So you use Kubernetes built-in controllers to run containers that implement your own custom controllers, which we call operators.
Let's break this down, right? So what we've said so far is a controller is just a program that's listening to the API and doing stuff. If I have a program in this day and age, and I want to deploy it somewhere, how am I going to do it?
Container.
A container. So if I need to run a container in Kubernetes, how am I going to do it?
With Kubernetes.
With a pod. I'm going to make a pod or a deployment that runs it with a single pod, and that's it. So this is where this concept of I'm in Kubernetes, and I'm running something that's just subscribing against the API.
So I think maybe an example is that if you used the out-of-the-box deployment, that would not be an operator, that would not be a CRD, because that's part of the Kubernetes core. If you perfectly replicated the functionality of that using your own CRDs, custom resource, and then this operator, it would be an operator because you are outside of the core, even though you're doing the exact same thing. The semantics are different from that. So like it's just a way to reference it that it's not part of the core.
Right. Okay.
With that said, the best part is, what do we call the library that lets us write operators?
Controller something?
Controller runtime. So it's like, we're all dying on a hill, I guess. So.
Talking to management and saying, okay, we have these people called operators that operate the system, and we're going to write this thing called an operator that is now going to do something, with Postgres or whatever else.
Yeah.
It's
Okay.
It's something that just is unfortunate, but now you know a lot of like, what do they call, like family generational trauma, something like that. Welcome to the family. Right. It sounds like Game of Thrones. We're gonna go to the next slide.
Second class citizens.
We're gonna do our own. This isn't like, let's write a complicated database. I just like deploying stuff, and I like when people celebrate deploys, myself included, even if it's my own deploys. So we're going to do that. And it's important, like we said, in all these examples, we've said, well, let's define what we need to know in order to fulfill on this, which again is, I want to, every time I deploy, I just want it to send like a super nice message to a Slack channel that I listen to. So when I deploy my code and it finishes deploying, it's just like, you did a great thing today. You should be so proud. Because we all need that. So I wrote this thing called Super Kudo. It's just a resource like a deployment. It doesn't exist yet. We're going to make it. And it has a name. And then this spec field here, it just has a selector, which is kind of a convention to say, look for a label. In this case, we're just going to see if there's a deployment that has a label app nginx, then I want it to deliver, and it finishes deploying, I want it to deliver to Slack at some Slack URL. Makes sense to me?
Wait, how do you know it's looking at deployments?
It's not. All I've told it is enough information so that the control loop or the operator we write knows enough information so that when it's looking at deployments, it can say, is there a deployment that's an app nginx label?
So is it the controller / operator that you have to like go look at its documentation to figure out what config things you can give it and what it will do with them?
Yeah, just like any program. If you have parameters or whatever to a program you can give it, this is like giving parameters to a program that runs. In YAML. So our steps here are just going to be tell Kubernetes about our custom resource so we can use them through the kube API. And again, all that's going to do is hold the data definition. Then we need to write a program that watches for changes to our custom resource with the kube API. And then we want to watch deployments and see if any of them match our deployments match our deployment selector and namespace. And then finally have a successfully finished deploy. After that happens, we'll send a message, but we're going to do it in Rust. And I want to introduce like two libraries here really quickly, which is kube-rs and Kate's Open API. Has anyone used any of these? How many people have written an operator or controller for Kubernetes? Nice. What, in Go?
In Python.
In Python? Okay.
And Python.
Oh, and Python.
And you should do it in Go. Don't do it in Python.
So he says we should do it in Go. And this is what I hope to take away going forward, because I know we're like deep in the mire of like, what is Kubernetes? And we just had this religious war over terms. I'm hoping that after we finish this talk, which we're like 75% of the way through, you will want to use these libraries for your next operator instead of Go or Python.
Ooh, that's a good goal.
I'm also hoping you convince me of that, yes.
Given you're here, it's probably a very low bar to get you over. So I know this isn't like great syntax highlighting, but the first thing we have to do is create our custom resource. And we're like, well, didn't we just make that in YAML? We did, but in Kubernetes land, for the kube API, we can give it like an open API v3 spec that just says like it should have deliver to, it should have a selector, and it's called a super kudo. And if we give that to the Kubernetes API, it will let us send things to the API and it will make sure it has all the fields that we've asked it to. So it's almost like we can tell Kubernetes API to do a little bit of data validation for us, which is really cool.
What's kudos dash keys?
I don't know, I gave it a group because that's what all the cool operators do, and I happen to own that domain. So
Oh, so it's like an actual domain name.
yeah, it's like a domain name.
Got it.
So derived custom resource, we're in Rust, we're talking about macros. One thing that's really powerful with this kube project is the macros that let you build all of these things necessary to not only create this resource definition that we hand to Kubernetes, it also generates a bunch of code. So you end up with something like an API client that you can use to talk to this resource. And it's similar to people who use SerDes for deserialization. Deserialization, it's just another derived macro on your struct. And this kube one gives it some information, like the kind, the name plural, and that we want it to use namespaces in Kubernetes. And what this outputs is like an enormously big custom resource definition object. We hand this to Kubernetes, and you can see it's just, like I said, an open API v3 schema that has properties and names with types and required fields. Bonus points for people who look at this and said, with Certi, if you make a field optional, then it's something that you can pass null to. If you're like JSON and you send a null value, it's acceptable. But if you don't put an option on it, then and you try to deserialize it or serialize it onto the struct, it'll fail. What's cool about this custom resource is it does the same. Notice these required fields here. It's required because on my Rust struct, I didn't give it an optional argument. I thought that was pretty cool. So this is how we can tell Kubernetes this superkudo resource, these fields will be required. And if you try to submit it without it, the Kubernetes API will reject it for you. So I copied that field over again so you can kind of see left hand versus right hand. This is our controller loop. This is it. Top, we have this API client that we use to listen to the type superkudo, which we just made in Rust. And the kube-rs has this controller object, which we now know what that means. And we say, use this superkudo's endpoint, which will subscribe to the changes. We give it this reconcile callback, which is this function down here. And then we just have like a for each that lets us process it asynchronously. And lets us know if it was reconciled or if it failed. And really all it's left to do is like fill out that reconcile function. The reason I wanted to show this is it's not just, even though we're just subscribing to an API, the kube-rs library will give you a bunch of helper methods to make writing just what you need to write a lot easier. The next thing I said we had to do is watch for deployments. And so I used intentionally a slightly different way of watching this code so you could see the same. We created another deployments API client, or another API client, this time on the deployment resource. And we use a helper function called a watcher, which will just make sure we're always watching. And if the connection ever closes, it'll just resubscribe and continue watching. And then for each of those, we will do something, like see if the deployment finished deploying. And if it did, we'll call some function on deployment completed. We'll use that as a method of sending a Slack webhook here in a minute. Someone should be asking the question, where the heck did the deployment type come from?
Where the heck did the deployment type come from?
I'm glad you asked. I list 2 libraries from this Rust stack. The first one is kube-rs. The second one is this Kate's Open API. This Kate's Open API library, it uses the fact that all of these resources are backed by an Open API v3 schema. And so if you use that schema, you can generate all of the Rust code that you would need to use it from an API client, which is pretty cool because if you're using someone else's operator, you know you can get their Open API v3 spec. You can go write your own little library like Kate's Open API and generate resources for someone else's operator, and then you can call back and forth from your code. So I thought that was a really cool call feature, but Kate's Open API is where deployment comes from.
So that crate just has all of the built-in resources.
Yeah, so deployment and everything else. The kube-rs includes the API client and a few kind of standard things, but Kate's Open API has deployments, services, config maps, secrets, endpoints, everything else.
So you're using both libraries?
You do need to use both because in this case, we want to watch the deployment resource. So we need the Kate's Open API crate to know where that resource is. The fourth thing we needed to do was send a Slack message. So on our superkudo struct, we just implement it because it's just a struct. And we can use the request crate to send a Slack webhook, which just needs a text field in JSON. and all we say is congrats, you finished deploying.
Where's like the authentication for Slack?
And this will show up. So where's the authentication for Slack?
Is it in a config file? Is it in YAML?
It's right here in our super CUDA. We told you the
Well,
Slack
that's
webhook.
that's an endpoint, but isn't there a?
Well, I just use this one, but we'll do a demo here if we want, and we can use a real Slack endpoint. I use this screenshot in case everything went to hell and didn't work.
Wise.
Thank you, thank you.
Yeah, I think that Slack webhooks just have a big, fast string of random characters, and that is your authentication that you can just
How's everyone feeling so far? Like, are we feeling good, or is this like, please just stop talking?
Good stuff.
Okay.
Is that Comic Sans?
I did this because we had a big conversation about not using mod in your main file, in your main RS. But I couldn't remember the workaround, and it was like 12:30 in the morning, and I just said, screw it, I'm gonna use mod utils and just let Nathan get mad at me.
Garrett.
And there he is, so true to my word.
Would you like us to help you fix it?
We can if we want, after the talk.
All right. I'll help you fix it after the talk.
We don't have to go through this whole thing. I highlighted the main things, but this is on GitHub, so you can go review it and run it yourself on your own cluster. But I just wanted to highlight a couple things, like you create an API client. In Kubernetes, you need this thing called a kubeconfig. As long as you set it, every API client knows to look for that. And what's pretty cool is your pods will also have Kubernetes configuration, and so you never have to set like your Kubernetes secret, because the convention here lets it create it automatically. So as long as you have a kubeconfig set, you're good to go. And then you can build whatever types you need. Like in this case, I wanted to make sure I always had a list in the app of all of our super kudos. So if a deployment finished, I can quickly check to see any ones that match. And then I just start a bunch of stuff. There's our controller. I don't feel like this is, like we just walked through the code, and I feel like at this point, if you really want to dive in, go look on GitHub, you can. But I will show one more thing. This is the CRD page. You should remember this from the slide. This time it looks a lot prettier because it actually has real syntax highlighting. And you can go through here and see some stuff. I showed that custom resource definition. YAML. This one. How did I build this? Like, where did this come from? I sure as hell didn't write it. It looks like OpenAPI-ish, right? The reality is I didn't write it. I used a build script, which we talked about at the previous meetup. In the build script, I have my kudo CRD, and I just say, great, every time I compile, take the CRD, this custom resource definition, YAML, which will generate, and I save it to this file in my repo. That way, I'm always committing the latest version of what the app has, as long as I'm building it. But that's where that file comes from. So, any questions about the code you saw, or anything that you want to see really quick?
So when you were doing the custom resource definition, maybe I just didn't notice it on there, but when you start adding, let's say, properties to that, because you have to manage, I don't know whether it's some hardware, software artifact, or resource in there, where do those properties get put in? Is that the spec regulation?
Yes. So by default, you put these under the spec. The actual superkudo resource is generated by the macro. So you just attach this to the spec struct. And then the fields on the spec, all you have to do is really add this JSON schema derived macro to it, which is on the end, on top of the sturdy stuff. And then the rename all to camel case, just to kind of match the Kubernetes convention of
Okay, so then your manifest file gets stuck in NetCP, and then the whatever the scheduler is going to put it on some kubelet, and then kubelets is going to deploy this logic to each, or have this logic deployed to it, and it's going to know what to do from there. I guess, is that the flow?
So what do we need to do now? Well, we have this super kudos-es file, and to load it into Kubernetes, we could just do kubectl apply-f super kudos blah blah blah. There it's configured. We can look at kubectl get my CRDs, and we see sure enough super kudos was added right there. This is a brand new cluster I started a minute ago. And then I actually already created a super kudo, but I can just get my super kudos that already exists. And I think this one is technically broken. So if we look at this super fun example as YAML, we can see I created a deliver to some test stuff. Let's go ahead and delete that one. Because over in Slack, I hid a real webhook. And yeah, you could totally like send random webhooks if you want to, but whatever. So this is a real Slack webhook. We'll load this into the cluster. And if we look at our super kudos again, it was created 6 seconds ago. If I look at my deployments, there are 4 of them. But if I just look at the default namespace, there's this one Nginx example file, and it looks like it's got a bunch of stuff in here. But the spec is just an Nginx container. Where are you? Containers, named Nginx, and it has the labels app Nginx. So I've tagged it so we can find it.
Why does it go spec and then something and then another spec?
So for a deployment,
Spec template spec.
so that's a very specific thing to deployments. The deployment needs to know the template for each pod that you want to run.
Oh.
So this is saying
So you're embedding
a pod template,
pod template in
and this represents what each pod should have.
The outer spec is your deployment spec. The inner one is a spec for the pods you want that deployment.
Exactly. So how do I run my operator now? It had detected that a deployment had finished. I kind of cheated here. I just let it scan all deployments because I didn't want to waste everyone's time deploying something else. But it said one, and then it reconciled. I think I did. Yeah, and it sent here we go, sending a kudo to some super fancy demo because Nginx deployment example finished reconciling. And if I look at my testing channel here, sure enough,
We got the message.
congrats, you finished deploying Nginx example. All right, don't let me.
God smile upon you.
Yeah, don't let me get off that easy though. Let's just do one more thing. If I go to fun, kudos. Oh. I think I have my fixtures deployment. Let's say I want to change this to version 14.3, right? kubectl apply -f fixtures deployment.
I changed my
Oops.
deployment.
That was my work config. It configured. It saw that stuff ran. I needed to make a better filter to only catch the test one. I wrote this at like 1 a.m. because I thought I don't need that much time for this talk. And here we get like extra congratulatory things for completing our Nginx deployment. Yeah, so we're basically at the end here, but I did want to say, well, why? We talked about Kubernetes, we talked about Rust, and now I want to answer why. Well, I hope you can see like the macros and everything were pretty slick, and the controller utilities were also great too. So why Rust? I'd say 90% or more is written in Go. Everyone here who's written an operator has done it in Go, which means you know what the controller runtime libraries are like. You have this huge makefile. It has this like, makefile has a pipeline that runs Go format, Go vet, and it also has to do multiple generators in your code to get it to actually compile with everything you need to run your operator. and you have a bunch of comments littered everywhere that look like this, and if you move them around, you'll break a step and it won't work. So it's easy to mangle things. The other reason is kube-rs, I showed you that API where we just say, I want an API of type deployment. In the Golang side, it's a little bit different. It's like dependency injection, insert your cartridge that tells you about a particular API, and then it's a bunch of like reflection to call it, and you're giving it these non-typed structs, and it'll panic on you if it is the wrong thing. It's not great, and I think kube-rs does it a lot better. So if you are writing an operator next time, I hope you consider Rust. We're done. You learn about Kubernetes, what an operator is and how to write one, and then I hope you use kube-rs next time you have to write an operator, if you do. Thank you.
Cool.
That's it.
Thank you, Garrett. That was fantastic.
Sweet.
Turn this thingy around, and we'll go and get out of this. Okay, so here's where we got. Oh, that's going to be fun to look at. Yeah. Okay. This is. I should like change the view or something. OBS. This one. That one. Okay, and then we'll hide OBS, and we'll open up Keynote, or let's see, I should just go to, oh, of course, thank you. What's new? Because we've done updates. All right, so go to, where's Dropbox in here? That's weird. Dropbox, where are you? They moved my Dropbox. Why is Dropbox not on my sidebar? Annoying. Dropbox, where the freaking heck are you? Okay, someone tell me where Dropbox went. Hello? You're running, right? Okay. Well, that's the one I want. That'll work then. No, that's the 171. We want Enums. Different one. I need to find freaking Dropbox.
It's cargo.
How do we open Dropbox in Finder?
Just a folder icon. So you can actually
I can try the folder icon. Folder icon?
and open the
Oh, you win. Thank you. I don't use this laptop much, you can tell.
I was writing an operator
All
that
right.
uses, it needed to make like some Istio service mesh stuff, right? And so I didn't want to like use a template that just slams raw text into the API client. So what I did was, and realized I didn't have to because somebody already else did, was use the Istio latest code, pull their custom resource definitions and like their standard install YAML, and then you can pluck those out and turn them into Rust code. So you could use it in your library. So then I can create like an Istio service entry or a virtual service just from Rust code.
So that's all well-typed and the Rust code is basically saying,
Actually,
here's
do-
the send to Istio, and here's all the slots I can.
So it's like use a virtual service struct, create a virtual service type data file, and then do your create on your virtual service. So that's what the type system is pretty awesome.
And then go to OBS.
And then you drop that into your Kubernetes.
Switch that to.
Yeah, that's where your logic.
And you just download the manifest or the, not manifest, but the Open API spec from there, from GitHub, or directly from their GitHub? Or
Yeah,
you-
but some people have actually built, like, given some tag, just go clone the tag as part of like their build step, and then they'll go generate the Rust stuff, and then they'll just release the crate that version. So like the easy Istio stuff, there's 1 or 2 open API for Istio crates on GitHub. Or on their site.
Cool, we ready? All right, so enums. So enums in Rust are more like algebraic data types in Haskell than they are C-like enums, right? Your C-like enums, they're integers under the hood. I didn't say useless, but yes, you're right. Okay, so they look like this, right? You have the enum keyword, and then you have the name of your enum, and then you have curly braces, and then you have your variants. That's what all your options are, is variants. Oh yeah, that, like we just talked about. And if we stop right there, and you just have the variant names like that, then it is actually sort of like a C enum, right? Just, they're different values that could be represented by an integer under the hood, and you can just like use them. You access them using the scope operator, so the name of the enum, and then colon colon, and then the variant, right? You can assign it like that if you want to. But the real power of enums, like you alluded to, comes from associating data and methods with the variants. So let's say we have an enum. So I got like a Team Fortress 2 theme going here, right? So we got like a dispenser, and it could be empty. There's like nothing in the dispenser, or it could have some ammunition in it, and there's some amount of ammunition. So it encapsulate an integer of some type, like a U8 here. You don't get much ammo, I guess. Or you could have like a things. Now this is a tuple of data. So you got just your positional, in your 0 index you got your string, and in your 1 index you got your I32. And you got to remember what the heck they are. Or if you don't want to remember, you can have an anonymous struct where you have actual named fields. So here we have X and Y, and they're both integers and all nice and cool. And then, when we actually use it, so one of the 3 places where I teach my students that is actually okay to use an asterisk in a use statement is when you're importing the items or the variants of an enum, but you ought to do that in like the smallest possible scope. Don't do that out in global, because that gets messy. So anyway, we bring the stuff into scope down here, and then you can assign stuff to empty or ammo or things or place, but the point is the enum can only be one of them, right? It's not like a struct where you have all of them, it's just one of them. And even better, you can also implement functions on your enums. Sometimes when people are learning Rust, they don't run into this for a while, and they don't realize, oh, they write a bunch of standalone functions, and it's sort of awkward, but no, you can, just like structs, you can make methods, you can make associated functions, as a, if you want like constructor-like things or stuff like that. Let's see, and then there's, let's go over option in the standard library. Option is an enum you'll run into all the time. It's actually a generic enum. So that type parameter in the angle bracket says, hey, any type T can be inside of that sum variant. So the sum is a tuple variant containing one item of type T, which is any item because it's generic. Or it can be a none. So option just represents, hey, I have something of some type, or I don't, right? And yeah, this is highlighting the different types. The T, like
this is the first time I hit generics in this course, so I say, well, you know, when you define generics, it's just an identifier. By convention, we use a capital single letter, usually starting with T, but it could be anything, but you usually use T. Let's see. So if you're trying to reach for a null or a nil value in some other language, that's when you want to use an option in Rust, right? You either have the value wrapped into some variant or you have a none. And I'll use option then to explain more enum usage here. So because enums can represent all sorts of data, you need to use patterns to examine them. You can't just assume it's a type of data and then like have a runtime check to see if you were right. No, you have to actually use a pattern so we can tell whether or not that it actually has that variant. So if you want to check a single variant, you use the if-let expression, right? When you put if-let together, that is a type of expression. If-let takes a pattern, so some x here is a pattern that will match one of the variants. So you can sort of, the pattern matching is pretty intuitive. Basically, you can replace where the variable is with an identifier of some type, and it will create that local variable for the scope of the if-let statement. So that x inside of those curly braces is a local variable created if that pattern matches. If the pattern doesn't match, then the condition is false and you don't run the block, just like, you know, an if statement. So this is really handy if you care about one variant matching or not, but if you've got a whole bunch of variants and you're trying to handle all of them at once, this is sort of awkward to write a whole bunch of separate if-let statements, which is why we've got the match expression, right? The match expression is like a switch statement in C or Go or a case statement in Ruby, etc. It looks like this. It lets you match on all the possible variants at once. So let's break it down. So you got the match keyword, and then the variable you want to match on, and then you follow that by your block, and then you have your body of the match inside here, and you start with patterns, so some x and none are the patterns in this case, and then double arrows, which is an equal sign and a greater than. And then you put an invalid identifier wherever a variant has some data, and then you can use that inside of your branch arm. And then, let's see, oops, did I go the wrong way? And then if it matches, it runs whatever you've got here. It evaluates the expression. Now, you can put a single expression in there, but here I've put blocks because a block of statements is an expression. So here I'm just printing out the value or printing out that there is no value. Match expressions do require you to write a branch arm for every possible outcome. In other words, patterns in a match expression have to be exhaustive. You can't just ignore some possible values. So if you're matching on an integer, there's a lot of possible values, right? A single underscore all by itself is a wildcard pattern that matches anything and can be used for a default or an anything else branch. And you should always put your underscore wildcard at the end because the match arms are evaluated in order. So if your wildcard is up at the top, nothing else is ever going to be seen.
Clippy warned you about that?
It might. It might nowadays. I haven't tried it, but I bet it does. Someone try it and let us know.
Alright, give me a sec.
I had no idea it did that.
You have the wild card on top.
No, it'll just be like, okay. At least the last time I tried it when I first made this 5 years ago.
I'm sure Clippy would find it.
Clippy should find
Clippy
it
surprised
for sure.
me. But I had no idea it did that actually.
Oh yeah?
I didn't know they were in order. I thought it was smart.
No.
It's not even Clippy. Rusty catches it.
Oh, nice.
Nice. So it's in Rusty itself. Cool.
Yeah. It just says unreachable.
So there is a lint for it, and it's in Rust itself.
Yeah.
You just needed to do your version.
No,
log.
it's just part of the normal unreachable code.
Yeah,
Lint.
exactly.
The warning.
You should have started your Rust version summaries like 4 years ago. You should have got it.
Yeah, I totally should have.
It's okay, we forget.
I'm sorry I didn't, back do everything that I started doing.
It's alright, you can do that next week.
Next week?
It's
Okay.
V1 versions, right?
What's that?
There's only 71 versions.
I actually thought about going back and doing it, but it takes me 8 hours
No, don't-
to do one.
don't do it.
So it's a lot of, that would be a lot of time. Actually, the thing that really stopped me wasn't the time. It was, I didn't think anyone would actually go back and watch them for the old ones. So anyway, okay. What was I saying here? So note that even though you'll often see blocks as an expression, okay, so I mentioned this before. You can use any expression. It doesn't have to be a block. You can put a bare expression, so like a function call or even a literal value is a valid expression. All the branch arms need to return the same type because, hey, Rust is strongly typed. So I should say all the branch arms need to evaluate to the same type. If you aren't going to use the match expression, then all your branch arms should evaluate to the unit type, right? Which is, well, okay, the easy way to do that is just put braces and then put a semicolon at the end.
What you had before.
Yeah, exactly. Like there, somewhere. Yeah, print lines. Those all evaluate to the unit type because we've got that semicolon, which means that the block evaluates to the unit type.
So there's one sometimes useful sort of exception to that is that you can return or panic or whatever in one of the branches or in some of the branches, and those match with any other type.
Or return, right? I think you can return from one.
Yeah, if you don't, what's the name?
If execution doesn't actually
Yes.
leave
If
the end of
if you diverge,
yeah.
if you diverge, meaning you never come back. Yeah, if you panic or if you exit or if you do any of that divergent behavior, that counts as
Right. If
matching.
the whole match expression never evaluates to a value,
yeah.
so if you exit the match expression,
Or even if a single arm is divergent, then that arm doesn't have to
it doesn't. Yeah, right. it
evaluate to
doesn't
the
have
type that the other arms
So
do.
in your example, then, if you just do, or if you go back to where your
This one?
next one.
Wait for it.
So if you did like return 42 and square return a string, that'd be fine. If you literally had return 42.
Oh yeah, and this was inside of a function in that exited the function. Yeah, that's
And you
another
want to
that's
say,
another way to
Let
diverge.
name
Yeah.
equals match my variable sum x, call a squared function, otherwise return.
Yep. In fact, a little later on, we'll see an actual example of using a return inside of a match expression that diverges. Yeah. Good, good. Yeah, I think we covered that. Oh, yes, okay. So, if you don't use the value of a if you don't use the value of a braced expression, then Rust lets you cheat and leave off the semicolon at the end of a brace. But if you do want to use the value the match expression evaluates to, then you've got to add that semicolon there at the end of your closing brace. So here I'm assigning the value that the match expression evaluates to the variable y, which means I need to have that semicolon at the closing brace.
Yeah, the whole match is an expression itself.
Right.
So it has a value.
Exactly.
But
So yeah.
Lets are not expressions.
No,
Lets
let
are
is a statement.
Always.
Exactly.
And so the semicolon belongs with the let.
Yes, technically that's true. Usually I just simplify it to put it after the brace if you use it, because most of the time that's how you do it. But yes, technically match is an expression, so you have to treat it like an expression. All right. So, and then let's go a little bit more in depth into option result, because they are the most common enums you'll ever run into, because they're all over the standard library and we use them all the time. So they also have a ton of helper methods implemented for them. That's really cool. Like back when I wrote this, I think I counted something like 45 helper methods. There's probably like 10 or 15 or 20 more by now. So anyway, let's take a look at option. We already looked at the definition, so it's the same definition we looked at before. It's used whenever something might be absent. So here's how you would create a none variant of an option, right? So I've got a let statement creating a mutable variable, and then I do my colon and I do my type, where it's an option, and then in the angle brackets I put what it might contain, right? But then I'm going to set it to none. right? If we ever use that option with a concrete type where the compiler can tell, oh, you're using it with this type, that means that you can leave the type annotation off, right? So then it gets a lot easier to define, to like set an initial value. So most of the time, you probably don't have to use the type annotation. There's a handy helper method called isSum that returns true or false if it's, true if it's the sum variant. There's an isNone, which is exactly the opposite. It implements into iterator, so you can treat option like an iterator over 0 or 1 items, and loop quote unquote over it. So
Which is not usually used for loops, but it's used for things like map and flatten.
yeah,
Oh,
other
that's where that comes from.
iterator
Yeah.
fanciness.
That's where map comes from.
Mm-hmm.
Gotcha.
But wait, isn't there option dot map?
Yeah.
Does that come because it's you get that for free because it's an iterator?
You don't do dot
no.
It's a different
But if it's like within some other structure and you want to flatten it, do sort of a flat map thing. I think that relies on the fact that it has an into iterator.
Yeah, the dot map method probably uses the into iterator. Probably, it doesn't have to, but it probably does.
I'm not sure if it does. But either way, yeah, I think it gets mapped, not because it is an iterator, but just because it.
Yeah, you're probably right.
Yeah.
It's a different map.
But it just gives you all the iterator
Map is-
functionality for free.
Map is iterator returns another iterator. Map on option returns an option.
Oh,
Yeah, you're right.
yeah, okay. Similar but different. All right. The other big enum we see all the time is result. So result is used whenever we might have a useful result or an error, right? There's no exceptions in Rust. There's just results. So here's the definition of the result enum. So you got the, this is also generic like option, but here we've got 2 generic types, right? And you notice the OK wraps one of the types and error wraps the other type. So just the distinction here is that your error is not the same type as your success value. Right. Also, we've got this must use annotation on top. Must use just makes it so it's a compiler warning if you ever just silently drop a result. Like if it gets returned from a function or something like that and you don't assign it to a variable or use it in an expression, then you'll get a compiler warning saying, hey, like you got a result, but you didn't use it. And that's because Rust really wants you to actually check your errors. We don't just set globals in some weird library and expect you to remember to check them. Not that any language should ever do something like that, but yeah.
Hindsight is 20/20.
Yeah, I know. Okay, so here I'm bringing in standard file system file into scope and trying to open a file because when we deal with I/O, that's where a lot of errors can happen, right? There's just all sorts of stuff that could go wrong. And so opening a file returns a result because maybe that file's not there. Or maybe it's there, but we didn't have permissions to open it. Or maybe it's there and we had permissions to open it, but the disk has problems. Like there's any number of things that can go wrong, right? And here, I'm just opening it, but I'm not doing anything with the result, so I get the compiler warning, right? Hey, you didn't use this result. So let's go use the result. So catch the result assign the result to a variable, and then we can just unwrap it. We'll just figure, YOLO, it's probably there. So we'll just crash, right? So this brings up unwrap, or unwrap just, if it's an OK, it unwraps it, it gives it to you. And if it's an error, it ignores the error, but it just panics, crashes the program. Well, I guess it doesn't really ignore it because it could show up in that crash output, but yeah. Oh, sorry, hand.
Just a quick question about unwrap. I think I know what happens, but when you're running the Tokyo runtime, you call unwrap and it panics, or you call panic. What happens? Does it crash the whole program, or does it just crash that one thread?
Let's see, Levi, thread crashing semantics.
So if you have multiple actual threads, it will crash that thread.
And if it's,
And
I believe
that
on,
will cause anybody that's awaiting that thread to get a result of error back.
Right. And if, I believe on all the major operating systems, if that's the main thread, it will
Yeah, if
also
it's the main
terminate
thread, it will crash.
all of the child threads as well.
Yeah.
In your cargo toml, you can set panic equals abort if you want it to just crash your whole program, which I tend to, because if I panicking, I want the program to crash.
Well,
But that might
it's
not be
not
for everyone.
just crashing the whole program though. It also does not unwind.
It means it's not gonna run your destructors and drop things.
Gotcha.
So.
Well, I don't care about that. Maybe I do. I don't know if I do.
Sometimes you don't.
Sometimes, yeah, you get to make the decision.
It's fine.
Yeah.
Like embedded code often has panic equals abort because
Okay.
you don't want to deal with unwinding the stack.
Yeah.
Embedded microcontroller.
Right.
You can't get a stack trace off anyway unless you're debugging. And in that case, the debugger is going to do it for you.
So,
Face.
if you have like smart pi threads and one of them panics, it does not unwind the stack. Is that just leaving resources? Is that a memory leak?
No, crash thread's not a memory. Right?
Panic does call drop. And in fact, there's a lot
That's
of-
what the unwinding does.
Mhm.
Every stack frame has things still allocated on it, and the unwinding goes through each stack frame and drops the things that are on it as it's unwinding back to where it was initially launched.
Maybe I misunderstood. Panic does unwind things or it does not?
It unwinds to the point where the thread was launched,
Okay.
unless you set panic equals abort.
Okay.
Which you would have to opt into.
Right.
And that's usually like Levi said, in embedded things or people who just hate unwinding.
I mean, if your program's simple enough and
Yeah.
you don't have, you don't want to try and recover anything, and you don't need to have a last ditch attempt to recover some partial operations somewhere.
You still get error messages if you have debug equals 1 on the thing. I still get stack traces, yeah. Yeah.
Yeah, good discussion. Okay. Let's see. Yeah. All right. The expect method, it's really similar to unwrap, except for if it crashes, it includes this message for you. So, good to know about. There's also a nice is okay method, really similar to the is some method on an option, returns true or false. So here, like this unwrap will, assuming this is all single threaded, this unwrap will never crash because I just checked to make sure it's an okay. And I can unwrap an okay without crashing, so. Question or comment? Sorry, I thought
Even
I heard something.
Yeah, even multi-threaded. We have
You'd have to be doing some dangerously unsafe stuff for multi-threaded code to crash.
yeah.
Yeah,
That's true.
yeah, it'd have to be pretty hairy.
Because you wouldn't be able to, because that wouldn't be available to thread because we don't have ownership of it anywhere else.
Trying to get this stupid camera pointed at something sensible. Sorry. Okay, that's it for the teaching part, and then we have like an exercise to go over.
So
If you guys want.
I want to, if there's anybody who hasn't gone through the set of methods on the option and result types, they are chock full of handy helper things
Mm-hmm.
that will help you to translate an option into a result, or result into an option, or provide a default if it's error or none, or run a method if it's error or none to generate something useful.
Yeah.
And those can help clean up, the pattern matching over results quite a bit, because, that gives you an extra level of indentation, and, it can get pretty messy if you have a whole bunch of results and
Yeah.
you need to actually deal with results rather than just passing the buck with the question.
Yep.
Clippy's getting more and more of the ideas built in all the time of suggesting you replace entire matchbox of code with like oh, actually option has this method for it. You want to it's like, yeah, it's really nice. I like Clippy.
Yeah, and anytime you find yourself like saying if is sum or you know, like using ifs or using matches, there's probably a much more succinct way to do what you're about to do.
Yeah.
Most likely.
If let else and question mark try operator are also extremely handy for those two.
Yeah.
Yep.
Yeah, and I lied earlier, I think, to Garrett, I think. Someone I told said we were going to see a divergent example. I forgot. That was actually in my try operator section inside of my error handling lecture. So that desugars to a match expression where it unwraps if it's an okay, and if it's an error, then it just returns. It rewraps the error in the error variant and returns it from the function. So divergent match expression.
So does everybody know why the sort of thing that Rust enums are called algebraic data types?
Ooh, do tell, because they are algebraic data types, and I know that's what Haskell calls them.
In the type theory world, a type is kind of like a set, meaning that the type represents all the values that inhabit that type. So if you have a type int, all of the possible integers inhabit int. If you have string, all the possible strings inhabit that type. So if you have an enum that is listing several different kinds, several variants, that's called a sum type, because the resulting type that enumerates over several subtypes inside it contains the sum of all the individual subtypes that can be in there. So if it's A holding an int, comma, B holding an int, then it holds all the ints in the A subtype, or with the A variant, and all the ints again in the B variant. So it's all the ints plus all the ints is the total number of things in that type.
So
Now, a struct type variant is what we call product type, because it simultaneously has all of the types in its fields. If you have field A int and field B int, then you have all of the possible A's and all the possible B's at the same time. So if you did any combinatorics, you know that all the ints together, the number of possible enumerations of that is the number, or the size of int times the size of int.
So wait, where does the word algebraic come in?
Well, it's because when you can combine, you have two operators, sum to combine types and product to combine types.
So is a struct an algebraic data type as well? Is
It's
that
the
category?
it's product type.
So the combination of enums and the ability to put structs inside your enum variants
Oh.
gives you an algebraic data type, because you can combine
Interesting.
the sum operator on types with the product operator on types.
Ah.
And that forms a type algebra.
Ah, a type algebra.
Whereas other languages that have structs, they have like a small piece of that. They just have technically a product type, but you don't have the algebraicness of
You don't have
an algebraic data type.
tuples. Or a tuple is the basic product type, and then variants with multiple subtypes within them. Not like the C variant, but the Rust style variant.
Right.
Those are the sum types.
Right. And you can nest them and nest them and nest them.
Right.
You can have a
And then
struct
you
and
can-
an enum
If you
inside
want
of a
to know
struct.
how many
instead
things
of
are
an
in the
enum.
set of this type, you can do the math,
Ah.
basically, by
I'm not gonna though.
I can add up these types, I can multiply the number of these types.
Yeah.
So the fun fact about algebraic data types is that you can sort of write down the equation of what it would be in terms of additions and multiplications.
Ah.
And so if you write out a type that way, and then you differentiate it, so you take the derivative of your type, you get something called a zipper type for the original type.
Whoa, wait.
And that's
I'm hearing the words, but I'm just getting terrible flashbacks from calculus is all.
yeah, it's sort of a.
How do I put types inside of a derivative? Does that mean you can integrate them as well?
So
I don't like where this is going. What about Z transforms? Can we take them into a separate domain?
I really don't know how far you can go with this. But
I do know that there's a negation type. in
Negation.
Somebody
Yeah.
somebody in my grad program told me about that, and I was like, you stop right there. I don't want to know anything.
let's say you,
He told me
you
there's
have
such a thing as a negation type.
a simple list data type that is either, you know, an empty list or an empty list and another element, right?
Like
So
a linked list.
Classic
Yeah.
concept.
Isn't that like the whole definition of Lisp or something?
Mhm.
yeah.
Yeah, it's concept.
But if you write out that data type and then you take its derivative, you end up with like, or maybe you have to get anyway. You end up with a zipper for that type, which is like the things that the path that you took to get to the current point,
Uh-huh.
the current element, and then the rest of it. So a
Wow.
zipper for a structure is sort of a type that represents a step in a walk of that data structure.
Huh.
So I think.
We should give
so
a
I
talk
just-
about this.
I just looked it up. So all it's saying is that if you have a finite set of operators, and in this case, the operators would be okay and error, but you could have n number of those, it goes through and tries to pattern match based on the parameters and then once it matches, it executes that one. That's all the algebraic that's on this. There's a finite set of operators.
So if you have like a U8, there's 256 values that can be an option over U8. I guess that has 257 values because we're just adding one, which is just a none. And I guess a product type would be if you have like.
Well, he was saying that the variants are the
Yeah, so the
possibilities.
U8 wouldn't be the finite. It's OK and ERR in this case. That's the finite. But if you had, for example, a string value in one and then another value in another, that's part of the pattern matching.
Because you're matching on the option, not the U8.
Yeah,
If you're
correct.
matching on a U8, correct, it's 256 values.
Yeah, but that's
Yeah,
not what it's
and
referring
matching
to.
You can match on the U8 too.
But you cannot match on a U8 and an error.
Yes, that is. Wait, an error. I thought we were talking about options.
Well,
So it's a
that's what I'm
functional
saying is like,
programming concept.
Oh, over here. Okay.
the option is an okay or an error.
Yes.
But there is no type that represents a U8 and something else.
Yeah.
Right. Right.
well unions.
Unless it's another.
So sort of the.
But
the-
we'll ignore that.
Which wouldn't be a U8 and
primitive-
something else, it'd
the
be
primitive
whatever that
sum types
Right.
you name it, right?
Yeah.
is not something that exists in Rust.
Okay.
It would be that you have to have a way to if you have two sets of integers, but it can either be the first set or the second set.
Like a left.
And so you have to have something to discriminate which one it is.
Right. And that's part of the pattern matching.
Yeah.
And a result is kind of doing that, I guess.
Yeah.
Well,
But
that's
not
that's
really.
pretty. Yeah. Anyway.
If
We'll
you
keep
got
going.
an integer,
We could
you
debate
have
this
a
for a long
0 or
time.
1.
So if you had an enum that was like a U8 and an integer, and then another variant that was a U16. So we're saying the set space is 256 plus whatever.
6,000 whatever, or 60,000 whatever.
believe
Yeah.
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 I certainly haven't dived into the detail. But it's a functional programming concept to where you do pattern matching based on a finite number of operators. in typical mathematics, your operators are addition, subtraction, division, multiplication, whatever those operators. In this case, it's OK and ERR replace the plus, the minus, the whatever. So
That's not exactly what I was getting at. That's a different way of thinking about what algebraic data types are. Right? It's the reason that you call it a sum type and a product type is because you a sum type of two types contains the sum of their values, whereas a product type of two types contains the product of their values.
Like the sum of all integers plus, I guess, the unit type for option?
Yeah.
Okay.
So that's like all integers and then 1 is the way you would think. So you know how if you have a polynomial equation and you take the derivative, you're going to end up with like a +1 at the end.
no,
With a +1 at the end.
It's because you have an x,
Yeah.
and then the
The
derivative.
derivative of x becomes 1,
Oh, okay, yes.
and x squared becomes 2x plus 1.
It's been a while since I've done calculus. All right.
Yeah, 2x is, and then
And then
So
2x
anyway.
is 2. Okay. Or no, 2x is 2.
x squared becomes
X squared becomes 2x.
2x, yeah.
And then 2x becomes just 2. Or 3x becomes 3. And so
Yeah, you're saying you
No.
can actually
I
write
probably do
those,
calculus every Sunday.
Hey, it's been a long time since calculus, so I
Okay.
could be
Wow.
making some mistakes there, but that's,
Okay.
but when you end up with a constant, that's like a type with that many enumerated values. And just 1 is a unit type.
I have to say, this is the first time I've had math flashbacks and Kubernetes flashbacks in the same user group meeting.
So, yeah.
I've done one or the
gave
other,
a-
but never both.
I gave a talk at Lambda Lounge a while back about purely functional data structures. And they all have, there's like an analogy between this data structure and, oh man, it's been so long and I've forgotten most of this, but they're representing a number system, basically.
No, interesting.
So where do you learn more about this?
Really big books.
Web searches.
Just type theory.
There's,
That like,
so they're good, are there better resources than the others, is really what I'm asking.
yes, if you want to know about
And do you
purely
know which is
functional
which?
data structures, there's like a canonical book about it that some,
Okazaki.
yeah, that one.
Okay,
It
what
is.
is the
Okay,
It's a really big book.
OKAZAKI. I don't know how big it is. I haven't read it. I want to read it.
I
But
think,
the cool
I think
thing-
it was his PhD thesis or something, which you can find for free, and then he elaborated on that into a full book or something, so.
The cool thing about purely functional data structures is that they're immutable data structures.
Yeah.
And immutable data structures are actually super useful practically because they are thread safe, for one, but also it's really just super useful.